And I am live, and that is cool. Today is 25th of July 2025, and the day is Saturday. No, fuck, the day is Friday, and 25th of July 2025, Friday. And yesterday I didn't stream because I had to go somewhere, but today I am back, and let's simply begin. Yep, I am live on YouTube. That is cool. Yep. CP31. And why is this? Okay, this is officially black mode. That is cool. Dark mode. Eating candies. Let me set up my Vim Tmux attach this, and why am I here? Start in new Vim, update whatever needs to be updated, and lazy. Terminal is also cool, and now I will set a timer, stopwatch actually, and time it. Okay, okay, cool. There are n candies put from left to right on a table. The candies are numbered from left to right. The ith candy has weight WI. Alice and Bob eat candies. Alice can eat any number of candies from left. She cannot skip candies. She eats them in a row. Bob can eat any number of candies from the right. He cannot skip candies. He eats them in a row. Of course, if Alice ate a candy, Bob cannot eat it, and vice versa. They want to be fair. Their goal is to eat the same total weight of candies. What is the most number of candies they can eat in total? What is the most number of candies they can eat in total? In okay, they want to be it to be as fair. They want it to be fair. Their goal is to eat the same total weight of candies. Okay, so I will start an iterator from right and one from left. Boilerplate 23 and n and the input a size n equals 0, I plus plus I less than n, I plus plus, and in ai. Okay, and after taking all the input, I will start int x, l and r, and l equals 0 and r equals n minus 1, and int sum left equals 0 and sum right equals initially 0 or n minus 1. Let's make it equal to the first. Okay, what are the limitations? N can be equal to 1, and if it is 1, then they should not eat any candy. Okay, so L is here, and okay, L points to the candy that they can eat currently, and so int s L, sum left equals 0 and sum right also equals 0, and while L less than R, I have to do C. Can I eat the candy from the left? And int s equals 0, and s plus equals ai, and here uh, and they will never have int s. Okay, individually they can never eat, even theoretically, greater than s by 2. The greatest sum when I go from the left while taking s by 2, and from the right, okay, can I read the right candy? First of all, I have to eat both the candies, and if there is no possible, then n equals to 1, then that, n equals to 2, then there is another case. If sum left plus a left lower than s, and how would I know otherwise? I can make it greater. Iterate from the right and from the left. Keep adding the left number, but till when? How do I decide that from now on I cannot add any number? Mm, If si a l s l, yeah, it has to be less than s, and some other thing also. When I add this, then I have to know that at some point. Oh shit, I can make an accumulative sum array, and I will know the sum at each point, and an accumulative sum array from the right, and cool shit. Okay, and yes, yes. I don't need this, I don't need any of these, and vis size is n, and initially everything is 0 in that. Let's make the size equal to sn plus 1. Everything is 0, and si plus 1 plus equals si plus ai. So it will be 1 indexed, and that will be 0 indexed. Okay, and now I have an accumulative sum array, and I will go from the right and also from the left, and find the same number. What will be the sum from the right? From the left, sum till now is this, and to find the sum from the right of that much, total sum minus the current value. Yes, that would be the sum at this point, and sum from the right will only keep on increasing at every point, and from the left will also keep on increasing. N square, I do not want to make this n square, n1, and 2 goes up till 10 power 5. And divided by 2, I need to find equal things. Total sum is s, so int mx, maximum sum is going to be s n divided by 2, sum individually the answer cannot be greater than S total sum divided by 2. And I go from right, and I also go from left. I starts at 1 and goes up till n plus 1, and somewhere is this, and then I will have the sum of the last one. Hmm. Start from here, keep adding, and some will start there. And if there is only one candy, then they cannot eat. But if there are two, while it is lower to that, and some, okay. Currently, let's start I at, I will go from the left and noise, yo. Shit, 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 shit. Time is ticking. Yes. S I will give me the some of the first I elements, and from right, for this I have to find a number that matches this thing, n n plus 1 divided by 2, and L comma R, L is 0 comma R is n minus 1 initially, and int SL is just SI, so I don't need SL. So what I will do is, while I will take a temporary arc and CL, and CL is just I, and current right is n minus 1 initially. So here, while S, current S n minus S current right, S current right, S current right. For the first one, it will give 0. That is, I think that is cool. Is lower than SI, and replace this Y1. While that is the case, keep on decreasing SR, and a few more things. I am changing CR, so CR has to be greater than equal to n plus 1 divided by 2. And yes, after that, while that, after this, I should have a good value for CR. And okay, after this, I either went past it Yeah, I guess yeah, I should be pointing at a CR value that is higher than what is required, and the sum would be if Sn minus C CR equals Si, then I have increased the value, then L equals, why do I even need L? I don't need L. Int sum max, answer is initially 0. uh, if that happens, then answer equals Si. Wrong, probably. Yeah, wrong. Okay, 0 is cool, but everything else is messed up. 7, okay, how many? So yeah, I need that. But is it correct if I go 7? 7 means here it is 0, here it is 6 is wrong, but 10, 10 is cool, 10 is cool, 10 is cool. But here 6 is, I gave out output 0. 0 is uncool. 0 is not cool. 0 is wrong. Here I could have eaten this much, and here I could have eaten this much. So 0 is cool. 0 is wrong. Otherwise, it is correct. So I do need L and R. I don't need answer. Answer is like no. L equals I minus 1. Uh, I don't need R. I only need L. L would be my answer actually. No, I need total, right? Yeah. So answer is not just I, it is I plus the number of elements I have chosen from the right, and it would be N minus CR. And I should see correct answers except for this. Why don't I see correct answer for this? Something is wrong. I start from here. So let me output for auto xs c out space. Okay. Okay. For second it is this. So yes, I go from here, and from the right I start from here. I see 14. 14 minus 14 is 0, so which is lower than 2. So I go to the left and I see 14 minus 13, 1, that is also lower, so I go to the left, and I am going to the left till, okay, it is because of the boundary. Yeah, CR has to be greater than, it cannot be equal to I. That is, that would be the only limitation. And I can go up till wherever it wants. And now it seems to be correct. Yep, now it is correct. And what are the stupid things that I did? I don't need this. Yeah, I don't need that. Okay, I want to 18 minutes. I guess, nah, 18 minutes is too much, but still. Is there anything wrong? I'm not thinking about optimization, I'm thinking about correctness right now. And AI, yes, I take in the input and I create the accumulated sum array, and I start from the first element, and seems like correct to me. Seems correct. Submit. F eating candies, division 4. And damn. Ah, wrong answer. That is horrible. Wrong answer is horrible. On answer 49, expected 0, found 2. Okay, I have to see the question then, which I won't be able to see, but I can do some hack. 10,000 and okay, TT. So, and B equals TT, and after taking everything, if T equals 10,000, right? 10,000, then do whatever I say here, do everything else in just else, and if this is the case, and if T minus TT equals 49, for first it is 1, yeah, equals 49 at that point, C out N, and then a new line, and then output the whole thing for auto X A C out X, new line. I don't need this, not this stuff, and then C out a new line. Go there, and code forces is slow, even though I deleted the data code forces gave to my browser. Okay, wrong again, but now I'll be able to see the question. Like right here. Okay, only one input, and it was this. So why did I output? Okay, why did I output 2 in this? While CR is greater than I, and here what is answer initially is 0, and I starts at 1 and goes up till n minus 1, and in this case would be 1, and would be 1, so 2, and okay, so I goes only till there. Okay, and while okay, first was this, so it came out. Okay, and CR has to be greater than I, and initially it was not, so it came out. Okay, only check this condition when they are not equal. Okay, so and I not equal to CR, right? Right. What is the name of the question? The question at eating not slash out. What was the question? One with something. I have one test case, n value is 1, and let's say 5. I still get 2, which is wrong. I is not equal to C, while I lower than CR, not slash out 1 1 5. Now it is cool, and I can remove this much and select everything. Paste. Let's see. Now I think it will work. Wait, I didn't check the base case here. Oh, okay. Yeah, wrong answer on test one. My bad. While I is lower than CR and CR is greater, I is lower, CR my can they be equal? I think they can be equal. But they cannot be pointing to the same number, right? They cannot be pointing to the same candy. And how would I know? Now it is correct, but 115. It is also correct here. So that is cool. Let's go with the latest version. GNU 23. Accepted 25 minutes. 25 minutes is not good. That is like way higher than what I want. 25 minutes is very high. Horrible, horrible. I want it to be under like 5 minutes. So 25 is way high. And what was the thing? And to be actually honest in this question, even though I did do this on my own, I need to have edge conditions. There has to be a specific theory or a structure which I have to use to make algorithms. And I would know that if I'm using that particular structure, then my algorithm would be correct. Yeah, a structure to check the correctness of an algorithm instead of trying and seeing if it will work. Now the next one and timer. Yep, timer starts. Fuck it. You are given a list of n integers. You can perform the following operations. You choose an element x from a list, erase x from the list, and subtract the. You can choose an element x from the list, erase x from the list, and subtract the value of x from all the remaining elements. Thus, in one operation, the length of the array is decreased exactly by 1 given an integer k. If find if there is some sequence of n minus 1 operations. Okay, so that I always have one element remaining, so that after applying the operation, the only remaining element of the list is equal to k. Okay. Okay, so I can first of all sort the thing, and I would also have negative numbers, so it is a yes no question. Okay, and given this, I need to find 5, and to get 5, it says yes. I can perform the operation on 2, and that would reduce this and this by 2. Okay, it will reduce the total sum. I want the total sum in the at the end to be equal to 2. and removing an element of, say, let's x, it would alter the total sum. I would of course be removing the element itself, and also the total sum would be changed by, let's say there are n elements, n into the number that I removed, that will be subtracted from the total sum. So initially the total sum was 8 plus 7 15, and then I removed 2, 2 into 4 8, 8 minus 15 minus 8 is 7, I have 7, and then the next element would be 4, not be 4 because I removed 2 from 4 would be 2, and if I remove 2, no, how would I have 2? Shit. If I remove 4, I get minus 2 here, minus 2 here, and 3 here. Okay, and if I choose minus 2, I will remove minus 2, and here this would become 0, and this would become 5 because I am subtracting minus 2 from 3, that would make it 5, and this would become 0. Shit. So I do not always have to choose the lowest number. Does there exist a sequence? Okay, I can even increase or decrease a number. Target number. I do not even know, want to know the order in which it can happen. Sorting is not the thing here because here I am going on not with 2 but with 4. So greedy algorithm would not work. So 4. How does removing a number change all the remaining numbers? It subtracts their value. If I choose 4 here and remove 4 from 2, I get minus 2 minus 2. Uh, it is not possible in this case. It is possible though. In this case, I want 17 and I can just choose 0 here. Here, I want 17 and it is not possible. Why is it not possible? Because the only option I have is 18, and choosing 18 would make this equal to 0. So that is wrong. It is possible here. It is not possible here. I want to have 4. I want to have K. I want to have 4. Let's say I here choose 2 and make this equal to 5. Then all the remaining operations, I need to remove all the remaining elements, and yeah, the order does matter. The order matters because I cannot start with 2. I need to start with 4. Even if I start with 2, shit, I want 5, right? 5. I cannot brute force this. It would be way high my pay grade. Their values can be very big. N is also pretty normal. 11934. It is not possible in this case. I want to have 4. Removing an element does change this number, but it also affects all the remaining numbers also. And I have to do exactly n minus 1 operations, k minus 1 n minus 1 operations, because I need an element at the end. x, I want to have x. Parity, I cannot change the parity. Is if all the numbers are even and my target is a odd number, then I cannot do that. Here I can, and here I can. That does not help. Subtracting one element, how do I choose? I just need to determine if it exists or not. That is all. Given an array, I have to choose one number, and that changes the whole array. Initially the array is only of positive numbers and integers. No, it can also be negative. The numbers can be negative also. Here for 2, you can choose an element x from the array, erase x and subtract the value of x from all the remaining numbers. This in one operation, the length is decreased by 1, and I need to do n minus operation so that at the end the only remaining element is k. So while getting to k, I have to do n minus 1 operations. Right, I have to do n minus 1 operations. And here I am making this equal to the, if I choose 7 first, then this becomes minus 3. This becomes this is minus 3, this is minus 5, minus 5, and that does not help. And choosing this would make this equal to 0, and this was minus 3, so this would become plus 2 and 0. So yeah, nothing, it would just become 2. What I can do is find the last number that I can that still would not help. Nope, that still would not help. I need to find a particular permutation of from these n minus 1 numbers from these, and in a particular order. That is why it is a permutation, and perform the operations choosing those elements starting from the left going till right, and at the end the remaining element, whatever it is, it should be equal to k. And it is possible here, it is not possible here, not possible here, it is possible here, but how do I land on that number? Here I have to choose 4, then 2, then 2, and 7 will become equal to 5. But why did that happen? Maybe I go to Xcode draw and figure it out. This is my initial thing. Stopwatch is ticking. This is my initial thing. Then how I know that I have to choose 4, then 2, and then 2, but I only know that because I went till the end, right? Till the end with my decision. I did some calculation that I choose 2, then I choose the what -2, then I choose 0, and this becomes 5. But is there a way that I can know this beforehand? And I think not, because choosing this would affect all the other elements, and so I have to make a decision tree. So at the start I have in this case 4 choices, and I can treat these two as a single choice. So at the start I have 3 choices: this, this, or this, and I make a decision tree. If I choose this, if I choose this 4, then what I have is -2, -2, and 5, and I try to make one of these number equal to 5. Okay, and but if I choose this, what I will have is 2, 0, 5. Okay, and if I choose this, then I have -3, -5, -5. And now again, in all of these, I have 3 more choices. So this algorithm is crazy if I'm going to use this, because at first I had 4 choices in total, but these two are treated as a single choice because they are the same number, so it does not matter if I choose this two or this two. And then if I had n choices in the first permutation, then in the second I would have n minus 1 for every n. That is why I'm multiplying. So this algorithm is like n fucking factorial algorithm. So no, this is bad. Can I optimize? Let's see. At any given number, what is the maximum range that I can reach? If let's sort this first, 2 to 7, right? If I want the maximum range, then I have to add numbers to this 7, or at least not subtract numbers from it. And if that is what I want, what I can do is take the second smallest number and first choose that number, but that would add, and choose that, and this becomes -2. This also becomes -2. Then I choose the second largest and the second third number from the right, and that would be, first I subtracted 4, this became equal to 3, then I added 2, now it is 5, and this one is 0, and adding 0 doesn't do anything. I have 5. 5 is the high. Is 5 actually the highest number I can have? No, I guess if I choose, okay, what I can do also is, instead of having these two, I can merge them into one. Like, does not matter if I have two twos or one two, because if at any point I choose any one of these, the other will automatically become equal to 0, because till that point every operation that has been done on 1 2 has also been done on the other one, and their values therefore be equal. And whenever I subtract, choose one of these, the other would become equal to 0. So does not matter any number of 2's I have, I can treat that as a single 2, but that is only a little optimization, not actually solving the problem. 247, 247. Shit, I cannot even think about an algorithm that I can use. Face cam is blur. Let me see. Shit. Face cam is blur. Oh, wait. Let me hide my screen for a minute. Face cam, I'm trying to fix the face cam, so just bear with me for a minute. It is back? Yep, it is back. Just a sec. Yep, now it is cool. Working. You can even see the screen. Yes. In this case, I cannot even think of an algorithm to choose a sequence series of numbers which would lead me to 5, which would lead me to 5, yes. Given a number like 2, 4, 7, I have to choose 4, then 2, and then I will have 5. But how do I know that? 2, 4, 7. I, as a human, only know that because I first chose 4, like by literally trying, and then I chose 2. This made it -2, this made it like non-existent, and this made this equal to 3, and then this became non-existent, and this became 5. I cannot even do any square thing. Yeah, and the total possible combinations would be n factorial. So brute force is of course not an option. To make 7 equal to 5, I need a certain frequency. At the start, I was thinking about here the initial sum was 7 plus 4 plus this, it would be 6 plus 7, 13. Initial sum was 13, and when I chose 4, initial sum became 4 into 3 minus 13 minus 4 into 3, and that is 12. So that is 1, right? Yep, that is 1. And then I chose -2 because this became -2. So -2 into the remaining number of elements, which are 2. So -2 into 2. Subtract that from 1. I would get 1 minus 1 plus 4, which is 5, which is what I want. But how do I do that? How do I figure out that I have to choose first 4 and then minus 2? I am stuck in DSA without tutorial. I cannot solve any problem and I am a beginner. Give me tips or any roadmap. Roadmap is this. You can do this. Take you forward. Strivers sheet. I'm also doing this and this is cool. I have like not done much, but this is all. This is the thing that I am doing. You can do this. This is cool. Yeah. Strivers sheet. Okay. It has been already 22 minutes for this question. I will go for 8 more minutes till 30. Think about something. And if I cannot do that, then I will go to the editorial and see what the actual thing is. I cannot think of any way to do this. The only algorithm I know is brute force. How can I optimize this? My end goal is to convert. I have x1, x2, x3, like that, like a lot of numbers like that, and till xn. And I have to choose at the end, I have to convert one of these numbers, let's say x I have to make it equal to k, which is the target sum, and to make xi equal to k, I have to choose a series of numbers in some particular order, except the number itself, except the number itself, except the number itself. Right, is that a hint? Except the number itself. I can choose any number. Except the number itself. Except the number itself. When I choose in this sequence 2, 4, 7, I am choosing every number, let's say, except 7. So does it matter if I choose? Yeah, the sequence would matter because I choose 2 first. Let's say initially the sum would be 13. If I choose 2, it would become 2 into 3, 6 minus 6, it would be, and this would go away. This would become 2, this would become 5, and the sum would become 7. 2 plus 5, 7, and then from 7 I choose 2, the remaining number, and this would become non-existent, so this would become 3. Yeah, so yeah, the order does matter. Minus 2 into 2, 4, this becomes 3. But if I were to choose 4 first, then it would be 13 minus 3 into 4, 12, equals 1. And then if I were to choose minus 2, this would become non-existent, this would become 3. If I were to choose minus 2, 2 into minus 2 here, this would become 5, in which case minus 2 will be non-existent, 4 was already non-existent, and this will become 5 by adding minus 2 to 3. By subtracting minus 2 from 3, 3 becomes equal to 5. So yeah, the order does matter, and I cannot iterate. So here the maximum number that I could reach after choosing any operation, any amount of operation, was 5, and the minimum is 3. Okay, if I have 1, 2, 3, 4, 5. And if I'm choosing 5 as the number which I do not remove, 5 as the number which I do not remove, then what is the maximum value that I can get? Let's remove 1 because it would be too much branches. So if I choose 2, then the array becomes 1, 3, 1, 2, 1, 2, 3. And if I choose 3, the array becomes -1, 1, 2. If I choose 4, the array becomes -2, -1, 1. And if I choose, I do not choose 5. That is the thing, right? I do not choose 5. And from here, if I choose, I could choose 1 or I could choose 2. Let's say I choose 1. Let's say I choose 1. If I choose 1, then I will have 1 and 2 in the array. If I choose 2, I will have -1 and 1, and I will not be choosing 3 because that is the last element. Here, if I choose -1, I will have -1, 1, it will be added, so 2 and 3. If I choose 1, it will be subtracted, -2, 1. If I choose -2 from here, it will be added, 1, 3. And if I choose -1 from here, it will be added because negative, so -1 and 2. And now in the third part, if I can only choose 1 here, so it will result in 1. This will result in 2, this in 1, this in 3, this and 2, this and 3. So I can have any number from 1 to 2. 1 2 3, any number 1 2 3. Okay, if I'm not choosing 5, that is 1 2 3. And when I choose 2 as the first number, I got 1 and 2. When I chose 3 as the first number, I got 1 and 3. And when I chose 4 as the first number, I got 2 and 3 as the only possibilities. Nah, I can have any number from 1 to 3, but how would I know that without going through this whole process? Because this process is very big. The time complexity is very big, n factorial. So I need some formula which can substitute this whole calculation. And I guess there is something that I do not understand, and thus I will be going to the editorial. B, this is division 1 and 2. Code 10. Okay, TON is like the open network. Okay, that is very small editorial for this one. Note that after deleting A, J, all numbers in the set are of the form AI minus AJ, since the previous subtractions are. Note that after deleting element AJ, all numbers in the set are of the form subtraction of. Yeah, correct question. Therefore, the final element will be the difference between the last element and the previous last element which was erased. Since the previous subtractions are cancelled, Did I read the question properly? Yeah. Note in the first example, we want 5. One way to achieve it is the following. First, we choose the third element, obtaining this. Next, we choose the first element, obtaining -2 and 3. And finally, we choose the first element, obtaining this. Shit, here this 2 did help. Here we chose this element, and so this 0 was helpful. It was not like not unhelpful, it was helpful. Okay. Note that after deleting AJ elements, AJ numbers, all numbers in the set are of the form AI minus AJ, since the previous subtractions are cancelled. Therefore the final element will be the difference between the last element and the previous element which was erased. Or the final element will be the difference between the last element. Yes, so we just need to check if K is the difference of two elements in the set which can shit. Okay, shit. Whenever shit. Okay, if I have something like this, x2, x3, a big array, x4, x5 till xn. So whenever I'm choosing any of these numbers, let's say I choose this, then I'm subtracting x3 from all the elements. So the individual difference between any two elements, let's say x4 and x2, is not going to change because initially their difference was x4 minus x2, and now after subtracting x3, I would have x4 minus x3 as the new value for x4, and x2 minus x3 as the new value for x2. And when I subtract this, x3 will be cut off, and their difference would still be x4 minus x2. So all I have to do is find two numbers whose difference is equal to the target number, and at the end just remove those two. So the final value that I have depends on the first number that I chose and the last number that I chose. So here when I chose 5 as the last number, and in this case I could have, I could have value 1, 2 or 3, because when I chose 2 as the last number, then I got 3 and 3 as the final answer. But when I chose 3 as the last number, I got 2 and 2 as the final answer. And when I chose 4 as the last number, I got 1 and 1 as the final answer. So I simply have to go n square and find all the differences, and if one of the difference is equal to k, that would be the answer. And log n, I can do n log n. Yeah, because I can sort the thing and then do it efficiently. Yeah, start iterating from the start and from the end. Keep going back, keep going back. If the difference is higher than k, then I have two options actually to reduce the number. No, I start from first. I have two options. I could come back from the start, or I could go up, and in both the cases, the difference would decrease. Yep. So which one do I choose? I could go n square algorithm. Need to check k is the difference of the two elements in the set, which can be done by sorting and using the double pointer technique. Double pointer technique. Okay, I will have to look up what it exactly is. Double pointer. I would have two iterators in a double pointer technique and start from one end and also from the start, and one pointer would be starting at the start and the other would be pointing at the end. One pointer here, one here, and I know since they are sorted, and I just need to find two numbers whose difference is equal to k. And these are sorted. And if these are sorted, then if I start from here and from here, maybe that is not how I start. N minus 1 xi, the difference would decrease. But how do I know to increase the first pointer or to decrease the last pointer? Using the double pointer technique. Two pointers technique, medium. Two pointers is really an easy and effective technique that is used for two sum in sorted array, closest two sums, three sum, four sum, trapping rainwater. I've done trapping rainwater problem before. Native method and and n square, that is what I was looking at. The very basic approach is to generate all opposite pairs and check if any of them add up to the target value. But I do not want their sum to be at the target value. I want their difference to be at the target value. And it is actually easier if I want their sum to be at the target value, because increasing the left pointer by 1 increases the sum, and decreasing the right pointer from the right decreases the sum. And if the current sum is thus higher or lower, I know exactly either to decrease the right pointer or to increase the left pointer. But in different, in when I'm calculating difference, decreasing the right pointer decreases the sum and increasing the left pointer also decreases the sum. So so but approach binary. Time n, it takes time n. uh, Two pointer sum, I'm looking for two pointer difference. So lead code is all, lead code also has description of stuff. That is cool. Two pointer technique. These kind of problems usually involve two pointers. One is slower runner and the other fast runner. Okay. Okay. One is slow runner and the other fast runner. A classic example is to remove duplicates from a sorted array which is available for you to practice here. Okay, there is another variant to that. One pointer starts from the beginning and while the other starts from the end. So I have to start both the pointers from one area. Let's say I start both from the start, and one is a slow runner, one is a fast runner, and the slow runner keeps at its position at the start, and the fast runner goes to right up until it finds an element with by element whose difference with the current number is higher than k, and if that happens, then all the elements to the right don't actually mean anything, and their sum would always be greater than k. So okay, okay. I can do this now after looking at the solution that is not on my own, which is sad. Int n, c, and not just n, I also need k. And k, vi, a, n, and I, 0, n, c, n, ai, and after that sort a, all a. Sort all a, and then int l, int r, and that is wrong, like, of course. L starts at 1 and L starts at 0, R starts at 1, and N cannot be equal to 1, right? Yeah, N is always at least 2, so we are cool in that case. Uh, L starts at 0, goes up till N, yeah, and then inside again, yeah, I don't need them here. R starts at L plus 1 and it goes up till N, and I goes up till n minus 1. I cannot be equal to the last element, and yeah. So while int r equals L plus 1, and while r is lower than n, and a r minus a l is lower than k. While this is true, then just do r plus plus, and after that, if a r minus a l equals k at any point, break, and bool then equals bool p, that is possible, equals initially, let's say, false, and here do p equals true, and uh, should I change the question here? This is the wrong question. Shit. This one was b subtract operation. See, shit. Yeah, subtract operation. And at the end, C out P question mark possible. If possible, if possible is true, then yes, else no. Right, and yeah, just that. Correct. That is the correct answer. I think it will work. Submit. Uh, in queue, running and wrong answer on test 2, which is bad. And is my camera still working? Camera is still working. That is fine. Expected no. Found 1 on 531. Token number 531. Okay. Why would you find 1? Expected no R is never going up till N, and L is starting at 0. R plus plus R minus L. Is this okay? Okay, and this shouldn't have broken, but anyways, int t equals tt, and after taking this, if tt if t equals 10,000, then if at any point t minus tt equals 531, right? 531, then C out N space K and new line, and then for auto X N, not N, N is not an iterator, A C out X space and then C out. Okay, and here delete all of this, paste here, and yeah, CPP still running here. This will allow me to see the question in which I got a wrong answer. I shouldn't have gotten a wrong answer, except if it is something C++ related, not algorithm related. Algorithm seems pretty fine. Here, this is the one. Why would I even output? Why would I output yes in this case? AR minus AL equals 0. Only then I'm making it equal to true. Otherwise, initially it is false. Okay, why am I saying yes to this thing? Client plus plus B subtracting operation dot slash out. I have one operation and 2 and 7, anything minus 1 and minus 2. I am denying the fact. This is the correct one which I got wrong, right? This one, this one. Okay, okay. What, out of range or something, out of bounds? Okay, 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 okay. Okay, yeah, this is okay. Algorithm was correct. Uh, if r lower than n and this. Okay, now we are cool. Select everything, go there and paste. This should work. Yep, seems to work. Probably this will work. This will work. And when it does, I want to look into this. Okay, so what was the fact that I was unable to figure out on my own in this question? It was that, okay, I did once say that the parity does not change, but that does not help. The difference between any two given elements does not change, and that was the thing, yeah, that I didn't notice. Because when I am subtracting, I am not just taking that number out, I am subtracting it from all of the given numbers. And when subtracting from all the given numbers, then I am, what is the one thing that is not changing? Yeah, that is what I should have looked for. What is the one thing that is not changing? And that thing is their difference. Yes, and how should I have known that? Because the time complexity is very big for the brute force algorithm, which is n factorial, and obviously looking at the time limit exceeded. Okay, so I am messing up something with double pointer method, right? Yep, something is wrong with my implementation of two pointers, which is this much. I'm sorting is necessary, but after that, this thing is wrong. Let me look at the actual code in that case for the double pointer method. Yeah, okay, sort I and j begins at 1, I begins at 0, while j is lower than I and n, and I is also lower than n. What do? We find what is, okay, you did some other things here also. A is the target, okay, V is the vector in your case. And okay, this is the way that you take an input. Okay, and answer false if n equal to 1, then and v0, then okay, if answer is 1, then if n equals 1, which it is not, it will never be 1. It is given in the question, I guess. Yep, n will never be 1, so I don't have to check for this. I can just go here, sort the array. Okay, start I from 0, j from 1. Okay, and then while this, if the element I current element from the left plus the absolute value of j equals j, then answer is true, and then break. Otherwise, else if it is lower than j, then increase I. If it is lower, if vj is too high, then increase I. Okay, and that is what I'm doing. Else increase j, which is the case when j is lower, and that is what I am doing in my implementation. although in a different way, but essentially that is what I'm doing. I go up till an R, which is lower R. Okay, that is not what I am doing. Yep, yep, these are fundamentally different. Yeah, mine is closer to n square, and his algorithm is 2n, not n square. So that is cool. And left equals 0 and right equals 1. Replace this with that. And while L lower than n minus 1 and R lower than n, do this for the current element if A R minus A L, if it is, let's check for lower, if it is lower than K, which is the target, then I need to increase L plus plus. Yeah, and else if A R minus A L, if it is greater than K, then R plus plus. Else we have our answer, which is you can do P equals true and break and CPP. This should work. It does not except for the first case. Why does it not work? Why do I say no in the first case? I sort it and then I do this 0. It should be 0 in the first case. That is, while this uh, right. So I plus minus R. R is at 1, which is 2. So 2, 2, 4, 7. This is my array. And initially L is at this 2, R is at this 2. Their difference is 0, which is lower than K. Therefore, I increase, which is lower. When it is lower than K, when the difference is lower than K, then I want the difference to be higher. That is why I do R plus plus, not this. And when the difference is higher, then I do L, right? Now it is cool. So I got time limit exceeded error, which is pretty noob thing to have. TLE eliminators. It is supposedly running and it keeps on running. Accepted. That is cool. And now I want to see, yeah. So what was the one thing that if I knew I would have done this in first try? That was the fact that I should have looked for one thing that is constant after every operation. What is one thing that is constant? And the thing that is constant after every operation is the difference between any two numbers. And once I knew that, I could have figured out then that I need to find a pair of numbers whose difference is equal to the target number K. And if I knew that, I do need to know about the double pointer method to actually find that. And double pointer, and how does the double pointer method work? If I have a bunch of numbers A, B, C, D, E, F, and they are in ascending order. So in double pointer methods, as lead code says, I have two two things. One is a slow runner and the other is a fast runner, and they both start either at the same location, like from the start, or one from the start and the other from the end, and they come below and merge and find the correct answer at some point. That try to triangulate the answer, but that would be in a case when moving the left pointer has one specific meaning and moving back the right pointer has one specific meaning. That would be in a case when I'm trying to find a subsequence that adds up to k, and moving the right pointer to the left decreases the total sum, subtract, and moving the left pointer to the right increases. No, it also fucking decreases the sum. Moving the left pointer to the right decreases the sum, and moving the right pointer to the left also decreases the sum. So that also is not the correct way in when I'm trying to find out a subsequence whose sum is equal to k. So they move towards each other until they both meet. Let's take a look at a classic problem. Reverse the characters in a string. Yeah, that needs double pointer. First, let's assume that we already have the swap function defined below, something like this, using temporary character, or you could use a R value reference in C. The idea is to swap the first character with the end, advance to the next character, and swap repeatedly till they reach the middle operation. Okay, that much is fine. And then I could practice this on these questions, which I can. Now, I will like to move on to the next question. And the one thing that I took from this question is that I need to, when the question has some operations to do, then I need to find out the thing that is constant between after operations. The one thing that is constant, the thing that does not change no matter how many operations I do. And 26, fun with even subarrays. And I will start the timer again. Yep. Be fun with even subarrays. You are given an array A of n elements. You can apply the following operations to any number any number of times. Subtract some subarray from A of size 2k that begins at position L, which begins at position L and where L is lower than 2 L plus 2 into k, okay, because size is 2k, and which is lower than n, okay, and k is always greater than 1, okay, for each I between this and between 0 and k minus 1, okay, inclusive. Assign the value, okay, choose some subarray of size 2k beginning at an index and assign the value for each I between these limits. Do this. I L plus k plus I equals L plus I. So the second half, which is this, becomes equal to the first half. Okay, for example this, and then choose I L equals 1 starting from here and k equals 1, so these two, and then my subarray would be this, so this would become 2 1 and 2 1. Applying this operation makes the array, yeah, change, assign the value this to this, okay, change the first half to be equal to the second half. Okay, find the minimum number of operations, possibly 0, needed to make all the elements of the array equal. Okay, I can make the first one equal to the second ones. So at the end, I would like to have some operation Yeah, so this number I cannot never change this number, so this number is constant. So I would like to have every other number equal to this number, because I can never change this number. So my first subarray would be like this thing, these two, and which would make this equal to 3 also, and then I would choose these four, and these two would also become 3, and then I would choose the remaining plus 3. Okay. So but I could also have 3 in the middle. I have to return the number of operations, right? Here they become 3, here they become 4. Here I only have to do one operation in these. So I start a pointer from the end, and I see the number of elements that I need to make equal to the biggest subarray that I need to make equal to this thing, and it would result in something equal to a log or something. BLE int n bin n, and then there is the array VIA size n I, or like that crazy cool for auto reference x and a c in x, and then I start from the end. So for int I equals n minus 1, I greater than equal to 0, I minus minus, I minus minus, and the screen may be too small for you to see. So no, not from n minus 1, but n minus 2, and int ll initially 0, and while I greater than equal to 0 and greater than equal to 0 and ai not equal to a n minus 1, that is the last element. What do? I do ll minus minus, and at the end ll is a longest subarray which is not equal to x, to the last element, and I need to first of all make this subarray equal to x, and how many operations would it require? I know that. How many subarrays do I already have? I need int answer initially 0, and int z equals 1, and I would like to make some optimizations, but later. And so size represents the number of arrays which the number of elements which have been converted. So while sz is lower, no, while ll greater than equal to z, while ll greater than 0, right? And while that is the case, first of all I remove from ll sz the current size of numbers that have been converted, and sz size doubles. Yeah, the size doubles, so multiplied by 2, which means left shift by 1, which is sz. Is that correct? Yeah, that is right. And answer plus plus. and at the end we have the answer, or it will just keep on running while LL greater than 0, LL minus, and SZ increases, answer in SZ minus and 1 minus minus, it starts at it starts here, LL plus plus, not this, and this still keeps on running, which is wrong, while LL is, and I am decreasing the value of LL. Oh, here I am not, shit, my bad. I minus minus. No, not I. And C equals I. No. I can do I. I can do I. Yeah, cool. Standard output. Is there something wrong with this? Can there be any error? Size. That is the number of elements that have already been converted. Answer. The number of times that I have done the operation, and LL initially is 0, that is okay, and I points to the current element that has not been converted, and I, okay, LL, the number of not converted elements, longest subarray, the size of the longest subarray that has not been converted, and while I is greater than this, and while the current element is not equal to the last element, and keep on increasing the size of the subarray, and also keep on decreasing I, go as left as you can, and while L is still something, keep decreasing the size, keep increasing, keep decreasing the size of the unconverted subarray, keep increasing the size of the elements which have been converted, and answer increases. I guess that should be correct, and I do not want to get this wrong. I want to get this right in the first go. And I guess, I think this will work, or maybe not. Shit. Expected 3, found 10. Okay, found 10, expected 3. When can my solution actually break? It can. Is there something that I am supposing? Z is 1. I'm always making it double, which is also correct. And doing this, while LL is greater than 0 is also correct. And the numbers are never negative. Even if they were negative, it wouldn't change anything. Take the last number, an minus 1. Size is 1, answer initially 0. Okay, I have to see that with my own 2 eyes then. The wrong submission. Let's see. The wrong one is shit. Pretty high up. In the third test case, verdict, wrong answer. Third, input size is 20,000. uh, int p equals tt, and here after taking input, if t equals 20,000, then if t minus pt equals, okay, now I'm going to use some crazy vim shortcut, which is control o and p, which is wrong. Shit. Okay, so I have to copy that thing again. And now I'm in currently in insert mode. So, right? Yes, I am currently in insert mode. Control O, P. Almost there. Control O, P. Yeah, good enough. And also, shit, this is equal. If this equals this, then C out first of all, N, then a new line, and then for auto X in A, C out X with a space, and then C out backslash N. Else, if that is not the case, select everything, and this would work in like locally. Yep, it would. uh, Submit. Submit. I would see the test case where it is wrong, which is this. I have 1,000 numbers and they are like this. Okay, and this is giving me wrong answer. One with even subarrays. Okay, makes sense. Okay. Makes sense. Makes sense. After performing each operation. Yeah, okay. After doing this, I has to change. I minus what? How many more elements have I changed? I have changed SZ elements. So, and CPP run. Yep, select everything, go and now submit. It should work this time. 16 minutes. 16 minutes is fine. Or maybe wrong. Okay, now the next one I expected. 3 found 7 and it is not the same one as before. I minus SZ. Okay. And while I am doing, well, it is not equal. At the end, I know that I have changed all of them. Okay, yeah. Uh, yeah. In that, I have to make SZ After every iteration, at least equal to I. Not, yeah, not I, but n minus I. Sz equals n minus I. Sz equals n minus I. I also changes. Sz also changes if I found them. But this thing, not n minus I, and not n minus 1, n minus I. Okay. The invariance is sz is the size. If I am at the end of the loop, then I know that the ith element at least has been converted, so that is cool, and I can do this. Sz equals n minus 1. See, 18 minutes is way too long for 1100 level questions. Now it says 2. Now it says 2. uh, for a bunch of ones from the right. And sz, after every loop, I go in here. I do not know about I know that all the elements from to the right of I have been converted. That is one thing that I know. So I go here and initial list ll, and while I is greater than 0, okay, and ai is not equal to the last element, that is, this number has not been converted, then I increase the size of the subarray and decrease I. Okay, and so those are the only two options. I either find a number that has been converted or not. And if not, then I increase the size of the subarray and decrease I. And do I always know that the ith number has been converted? No. If I break out of this loop, when ai is a number that has been converted, yes, that is when I break out. And when I do this, so at this point when I break out, I know that the ith number is like correct. I do not have to change it. So then I go here, while ll is greater than 0, I do this. ll minus size is the maximum number of elements that I can convert, and size becomes equal to 2. Answer increases and I decreases by size, but I is already pointing to a number that is like not converted. So if ai equals a n minus 1, then I plus plus. That should work. Ooh. Uh, if I just find, yeah. mm, mm, oh shit, yes, here, here I know that sz has been converted, so I equals n minus sz, n minus sz. And if that, then I don't have to do this. Oh, I can do this. Does not matter. That is cool. I equals n minus sz. Yep, that should work. Submit, and it has not worked. Like shit, 23 minutes is too much. Yeah, now it is. Now it is cool. You're gonna stop the timer. 23 minutes is way too long for one question at 1100 level. So let me first see now. What was I unable to figure out? I knew from the start, that all the numbers have to be changed to the last number. And okay, the only mistakes that I was making were in this, in the implementation, in the fine tuning of the algorithm. I got the algorithm right away, but implementation is the thing that took most of my time. Yep, little details like subtracting I was the first thing, and then these these three I added at the start, but these two lines, this line and then this line, they gave me error. Yeah, so that was the thing. And now let me read the editorial. Or does that say tutorial? B, fun with subarrays. It is not possible to modify. Yep. And then think about the leftmost x such that, yes, leftmost. Uh-huh. And shit, okay, that is quite big. What is the time complexity of my code? For my code, I'm just running one loop from the end to the first. That is just n. So, which is this? Uh, yeah, for simplicity, let b1 be till bn equals n be reversed. Okay, so b is the reversed array. The operation transforms to select L2R or the length 2k. Yeah, I don't have to read this. I can go on to one more question. I would like to do some questions. Find the invariance, the thing that is not changing. Now, the fourth question of the day, and already 2 hours. You are given an array A consisting of n positive numbers. You have to choose. Wait, start the timer. You have to choose a positive integer d and paint all elements in two colors. All elements which are divisible by d are painted red, and all other elements will be painted blue. The coloring is called beautiful if there are no pairs of adjacent elements with the same color in the array. With this, it is called beautiful. Your task is to find any value of d which yields a beautiful coloring, or report it as impossible. 0 means impossible, I guess. Okay, d can be very big, and if there is no such answer, otherwise print 0. Okay, can I need to find a number, the greatest common divisor, GCD of all like alternative elements starting from one to the next, and n is this. Find d GCD, which would be equal to the GCD, and And now if the GCD divides any of the other elements which are not supposed to be divided by that, first of all I have to find the GCD, that is the greatest value of D. Then value of n is not higher, and this is this, so find their GCD, find GCD of this. Okay, here the answer is 0. Here it is 1. GCD of 1, and there is no next element, and 3. Shit, okay, I will find 2 GCDs. GCD of this and the other pairs. Okay, here the GCD and this would be 100, and 100 I can choose, just choose 100, and the GCD of this of the other would be not 100. I guess GCD takes time, that is why the limit is high. GCD of this and this would be 5, so there would be no answer. Yeah, it says 0. GCD for this and this is 1, and for this and this is 2, and so the greatest value of D could be 1 or 2, and if their GCD are not, if their GCD is equal, then I cannot remove any number. Yeah, if I remove any number, it would make the answer GCD between 100 and what is this? I can not remove any number. It's either their GCD is not equal. If one of their GCD is greater than the other, then I find the answer, that then I output the greater GCD, otherwise I don't. And shit, there are edge cases, I'm not able to think about them. GCD here is 3 and here is 1. Yeah, yeah, let's see, I think this will work. BLB 23 int n, CM n, and VI in size n, and for auto reference x in a, C in x, and then two GCDs are int G1 comma G2, both are initially like 0, G2 equals 0, and for int I equals 0, I less than n, and I plus plus. Not just this I plus, and yep, there are only two elements. Yeah, so G1 equals GCD G1 comma AI, and G2 equals GCD G2 comma AI plus 1, and at the end, if G1 not equal to G2, then C out maximum of G1 comma G2 with a new line, and else C out 0. This should work in at least. Why does this say 0 and this says 0? Why? What are the first one says? Okay, shit, yes, because I I plus equals to. Now these two are wrong. The second last says answer is 2. GCD of this is 1. Here it is, yeah, for this pair it would be 1, and for this pair it has been 2, 1, 1. Yeah, it is 1. So for this it is 2. Okay, and if I do choose, yep, then I have to iterate. With that GCD. Okay, makes sense. After finding these two, then I have to know for sure that choosing one over the other does not mess it up. So therefore I would have to go through the n numbers again, and if I do find it, then I have to know that I can reduce the GCD, and I cannot just reduce it. I have to divide it by 2, or I could divide it by 3, I could divide it by 4, I could divide it by 5, I could divide it by 6, by 7, but I also have to make sure that it does not mess up the numbers whose GCD it is supposed to be. So GCD, is there a lowest common multiple? Would be 1. Yeah. After finding the GCDs, I have to go through the loop again, and I equals 0 and I lower than n minus 1. After this, I have to see that. Oh, if they are not equal, I can just, no, I cannot just output. If they are equal, even then, maybe can I choose some number? No, so this would not work. After finding the GCDs, okay, and n is not big, so I can go through n very fast, very fast. And log, the maximum is log 1 2 3 till d. Okay, this is the maximum, and the minimum I can choose d. The answer to be is 2. So do I iterate from 1 up till D? No. I could have, and I have two ranges from G1, from 2 to G1, and the other from 2 to G2. Okay, let's go with this. Uh, let's G2, G1, okay, first GCD, second GCD. Okay, okay. Okay, let's first go with G1. Let's say the group that I'm choosing is the first group, and that is the group that I will be dividing the numbers by. So for nothing, I have G1. No, int, yeah, I is starting at 1 up till G1 plus 1. Yeah, so that it becomes G1 at some point. What I have to do is see if for this value of G1, shit, for this value, for every value of G1, I have to run a loop and I0 in the array, and see this G1 has to divide every element in the first group and not divide every element in the second group. So if remainder for with the first group, and I will be moving group by group, something like this. Here, and if the remainder with the first one has to be equal to 0. So if AI remainder with G1, if there is a remainder, if there is a remainder, then I can not just break out of this for loop, I can break out of the outer for loop. Then P equals false, that is possible, equals false. Let's begin with uh, bool P equals true and P equals false. If not P, then break, yeah, P, make P equal to false, and if there is a remainder, then break, of course. And if this is like fine, if I'm not broken, then the remainder with, if no remainder with AI plus 1, remainder G1, current value of G1. If there is no remainder, then also break. But could it be possible if I choose a smaller value of G1? Yes, it could be possible if I choose a smaller value of G1. And if I come out and I see not P, only this is the thing that is making P equals false. If not P, then break and go to the next one, and if P, then also break. No, if okay, so there are two reasons that I could come out of the loop. Three reasons actually. That first is this, that this thing is true, and if this thing is true, I want to get out of this. So P G1, let's say initially is true and make this P g1 is false. That is, it is not possible with g1. So go someplace else, and it is not possible with g1. Go someplace else, and that is first condition. Second condition, if there is a remainder with this, and if there is, then I would like to do g1 divided. Okay, I will have not just g1 divided by equal to I, right? And then if this, then just break, and if not this and not this, then we are cool. So when I break because of this, or I come out of the loop naturally, if I replace this by j, and if I remove this one, replace this by j, and replace this by j. So I have to make a distinction when breaking through this or breaking through this, and the distinction would be if pg1, then just break, and if I break because of this, then I need to output the answer. Yeah, right, the answer equals -1. And if I break because of this g1, wait, if I break because of this, I can make g1 equals 0, because it will never be equal to 0. And if g1, if g1, if not g1, if g1, that is, I have found my answer, then also break. And now if g1, okay, and if pg1 possible with g1, no, pg1 is false. If pg1 possible with g1, that is, this is true, and also g1 is something, and g1, then see out g1, else do the same, do the same thing with g2 actually. Or I could just do this g2, g1 equals g2, and after this, the only condition, if pg1 23, copy 22 down below, see out g1, else see out 0 with a new line. Wrong answer for everything else. Shit. I said one here. One is never uh, right choice, and if G If not G1, remainder I. If there is no remainder, only then do this. And do the same thing here. This whole thing. Shit. It says 0. It says 10 here. 1, 2, 3, 4, 5. The answer is supposed to be 2. Okay, I'm doing something fundamentally wrong here. Make G1 equal to G2 and go through all the things again. Okay, what is the lowest number that I could choose? The lowest number I could choose is 2, right? And above, the highest I could choose is G1 and G2. So, okay. And then the next number that I choose has to have a remainder with at least G1 or at least G2 equal to 0. So after finding this, so for int I equals to I less than G1 and I less than or equal to G2, I less than equal to G2 and I plus plus. Now, if remainder with G, if not G1 remainder I, then we are cool, or not remainder G2 I, then also we are cool. And if that is the case, then I know that I can go on with this the parity difference. Okay. Okay, and then I go on dividing, and n is at least equal to 2. Int f equals a0 remainder, no, uh, bool f equals a0 remainder with I, and okay, f means if that is the first, f means that f is true when the first element is not divisible by I. That means that the second element should be divisible by I. Now I will start a loop I0 till n less than equal to n, and if at any point I find that this is not the case, for int I equals 0 and I less than n minus 1 and I plus equals 2 at every point. If I find at any case that AIF is not equal to AI remainder with I, replace this with J. this this with J, this with J, and here also this with J, this with J. No, this is I. No, this is I. Like this, then break, and initially I will suppose bool p equals true and p equals false and break. And for the second, if f equal to a j plus 1 remainder with I, then the same thing, p equals false and break. And here, yeah, if even after checking if p, then I need to do, I need to have p here. Initially I'm choosing this, and for every value of I am doing p equals true, and if p, then break. And if p, then see out. How do I see the answer? Yes, yes, yes. And answer initially is like nothing. At here I do answer equals I, right? And then 17 answer I, or I could do answer initially equals 0, not I, that answer, and else if not p, then C out 0 with a new line, and I can delete everything below here, below this point. Yeah, that should be cool. Or maybe not. Shit. It says 4 here. It says 0 here. Am I starting? I'm starting I at 2, so answer was true. Answer was true. If P break, okay, and I did change answer to I, which should have been 3, and I do this in the third case when 1 and 3, if no remainder with 2, then 3. Yeah, 3, it should have been 3. I should have gone into the loop and seeing that the remainder with the second one is 0. I should have gone inside. I should have gone and bool f equals 0. So which is remainder with 1 is something, right? So f becomes false, f becomes true actually, and answer equals I. Answer should have become equal to 3. Why is it wrong then? And 4, I guess 4 would work. 4 would work. And I say 0. I should never say 0. And here I'm saying 4. And here I'm saying 2. Why would I even say 2? Here I'm saying 4. 4, yeah, 4 is correct. 4 is correct for this. But why am I saying 2 in this? I say 2 in this. 2 does not make any sense. Right? 2 does not make any sense. If P, then break. I am saying 2 in 15, 5, 10, 5, 15. So let me simulate and 15. And here the answer should be 0. So see out G1 and also G2 space G2, run this, and for the first one it is 1 and 2. For the second one it is 10 and 15, 10 and 5. It no, it should not be 10 and 5 here. In the second case it should be 5 and 5. 5 is the GCD between this and this, and between shit. Mm-hmm. G1 and G2. Why is G1 10? And it is 10. So GCD between. Okay. There might be last two elements, or there might not be last two elements. Okay, 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 okay. Okay. 10. Okay, okay. Makes sense why it is 10. So I have to only change for G1. Right? Yeah, yeah, yeah. I only have to change for G1. So if n remainder 2, then G1 equals GCD G1 comma the last element, which is an minus 1. And now I do see 5 5 5 5. That is cool. And wrong answer. That is better than before. So I'm saying okay, so 4 is correct, but 0 here in 2 and 3 is not correct, which means I started with 2, right? And when D equals 2, C, is it divisible by at least one of the GCDs? And the GCD in this case is 1, and in this case is 2, and 2 is not divisible. So I go up to 3, and I see that 3 is divisible by the second GCD at least, that is G2. And if that is the case, then I go in and I make F client plus plus C paint array, C paint array, and I am taking a lot of time in this. 2, 1 test case, 2, 1, 3. Says 0, but it should not say that. C out I. Clang dot slash out 1 2 1 3. It says 0, so it is never going inside this loop. Okay, so let me also output G1 space G2 clan slash out 1 2 1 3 1 and 3. So the GCDs are correct, and I am starting I at this. And why didn't I output any I in here? I outputted the GCDs. Okay. Okay. I am starting here. What if both of the GCDs are equal to 1? So I only go in this if at least G1, if G1 greater than or both of them have to be greater than 1, greater than 1, and G2 at least one of them, or G2 greater than 1, which is 2. Only then do all of this, which is this much, and this much. We'll then do this. Else, if that is not the case, else I can see out simply this thing. I can do this. Oh, wrong answer for this. Okay, now it is correct. Hope it is correct. Wrong answer on test 2, which is horrible, and already I have taken 38 minutes, which is a lot of time. For test 2, I say no answer, but the jury says that there is an answer in test case 9, which is 1 2 3 4 5 6 7 8 9, which is 2 4. I could choose fucking 4. Okay, I could choose 4, and I don't choose 4. And out one test case, test 2 elements 2 and 4. I say 0. Why do I say 0? For the first one it is 2, and for the second one it is 4. And also, why am I outputting the answer multiple times? Slash out 1 2 2 4. Why do I say 2 4 and then 2 and then 0? Save this, right? Uh, okay. Because of that, clan this out 1 2 2 4. Okay, I do say 0, but why? One is 2 and the other after this, and the other is 4. So at least one of them is greater than 1. So after that, answer is 0. I start at 2 and at 2. Okay, it does divide at least one of the GCDs. So I move forward. Boolean A 0, remainder. It should be false. And okay. P will become false. So I break. P is false. I break. Not possible. Why am I being so hasty? Why do I have to break? If P, that is if true, then break. Okay. And here for J, first I checked with this and that was cool, that was true. And then I checked with the second element, and if it is equal to F, remainder, that is 1 0 in this case, and 0 is 0, then I should have broken, and P should be false. So I should have gone to the next iteration where I equals 3, right? And 3 does not divide any of them on any of them, so I should have gone for 4. See out I uh, line that function out for 1 2 2 4. Yeah, I does go up to 4, so when I becomes equal to 4, I should go inside, and I see that with the first one, remainder is 2, and which means true, right? True. And answer is I, which is 4. So I make true equal to this, and while J, yeah, right, first number, and this, okay, and then if J is not equal to AJ, remainder 1, remainder with I is 4, and taking remainder of 2 with 4 is 2, and that is true. If it is not equal to, wait, is false being converted into true here? Shit, okay, I can fix that like this, right? Bool, and if it is 1, then I want, okay, this should do something. And so now both of them are Boolean, and I'm comparing Boolean with Boolean. And for 4, remainder should be 2, which should be converted to 1. That is true, and true are true, so I do not go into this. And yes, and then I check with this. F is true, and remainder with 4 for the second number should be false, should be 0, and 0 is not equal to 1, so I do not break, and I go till the end, and I see that, right, I see that, and I break, and that's smash out. 1 2 2 4. Now that is actually correct. So the only problem was this, and one more thing I have to check after this. If n remainder 2, then I have to check with the last one, that if f is not equal to boolean of a n minus 1 remainder I, if that is the case, then p equals false. Okay, I want to get this correct now. I have only done 4 questions today, at least in the stream. I have only done 4. Running on test 2. Okay, running on test 3. Time complexity. That is messed up. Time complexity is too high in test 3. For something like this, answer is not possible. Yeah, I would output 0. For this, I would output. Okay, time complexity, time complexity. Yeah, that is pretty big. 10 numbers, and these are the numbers, and I'm taking GCD of these very big numbers. N is not big though, but taking GCD of these big numbers is pretty hard. So I guess at this point, the bottleneck is this code, this much, when I'm taking their GCD. Yep, that is the bottleneck. Ah, shit. It has been actually quite a bit, and I guess now in a while I will be ending the stream. 49 minutes, 50 minutes on one question. Um, uh, shit, this is one of the bad days. I have been unable to submit. Shit, this is a horrible scenery. But it is fine. It is fine. Some days will be good, some days will be bad, and yep, battery is running low. Okay, so let me first summarize and then I will be ending the stream. I have done 3 questions till now. Eating candies. So in this question, I had to see, yeah, the problem was just fine tuning the thing, fitting edge cases in the thing, and I had to start a number from the start and a number from the end and go go as far as they could. Start a pointer from the start and a pointer from the end, and for every point of I have to find a point in J that is good or not good, and the time complexity would have been 2n, is 2n in this case. And in the second question, subtract operation, I had to see that the invariance was that their difference does not change no matter how many number of operations I do. The difference of numbers does not change. That was the invariance, and I just had to do that. and then I had to sort the array and find a pair of numbers where the difference is exactly equal to the target number, which is k. So the thing that I need to figure out was the invariance, which is that their difference does not change. And with this, fun with even numbers. In this, there was also an invariance, and it took 23 minutes for me to do this one. And yeah, in this, I figured out immediately that I cannot change the last number, so I have to change all of these numbers. And yeah, the problem in this was only fine tuning, which was also the problem in the first case, and also the problem in the third, in this current question. So in all the three questions, the problem that I did face was that fine tuning thing, that I got the algorithm, but then I was unable to implement it in a way that represents the algorithm in a correct way. So yeah, I have to think about edge cases and stuff like that. And that would be that would be the end of today's stream. Today is 25th of July 2025, Friday. Yeah, and thank you for